The work CRISPR-Cas9 has surpassed in a way the frontier of knowledge through really showing a work done on really basic research work done on bacteria that has led to a transformative genetic engineering technology that allows to modify DNA and the expression of DNA in an unprecedented manner, because it's a very versatile technology that can be applied to the modification of genomes and their expression in a large panel of cells and organisms. CRISPR-Cas9 as a very versatile and powerful genome engineering technology has really a lot of implications and positive implications in the field of life sciences in general. So the agriculture field, the biomedical field, the research and development field. So it's really helping, for example, in medicine, the finding new targets for therapeutics, understanding really the basic fundamentals of diseases. It allows to generate animal models that are useful to understand better the diseases in a more close to a clinical situation, and can also allow to use those animal models to test therapeutics under development. And with one of the challenge is to develop CRISPR-Cas9 as a direct medicine to treat severe human genetic disorders. So this is an example, at least, of the broad applications of the technology in the field of biomedicine. And in the field of agriculture, for example, it's to really improve the production of plant crops in a very precise manner, and also allowing to really reconsider the way we really think of production of plant crops in the future. It's very worrying when there is a reporting that can challenge issues which everyone knows are real issues. So a way to circumvent it's really to continue research and prove those people who do not believe in climate change or do not believe in the need of vaccine development to really prove them wrong and show that there are means to believe that these are in any case real issues, and that they have to be tackled more in an emergency manner and in a very serious way by increasing, for example, also the awareness of these issues in the media, and by increasing the funding that allows to continue to focus on basic science and allowing young scientists to really continue in this field. The main motivation for me to be a scientist was curiosity, the possibility to increase knowledge in a certain field of science that was of interest to me. So it's I started with my interest in medical microbiology, and along the way in my career I've always been interested in basic science that could lead to the possibility of discoveries helping the field of biomedicine principally, but also life sciences in general. So it's really the curiosity that has been the driving force for me. The possibility to ask new questions, and surely, let's put it that way, the fact that I always liked very much doing science, starting from a master's student to now when I'm leading a team, For the young generation, I would like to really tell those who feel that they have an interest in science to take the chance to really pursue their interest and not ask themselves too many questions as long as they like what they are doing. That at least my experience has been that you never know what can happen to you in the years to come, and that in principle one has to be open and be sure that there is always a way in the system to continue science long term, and to be to follow their gut feeling, their enthusiasm, and the fact that it's really a luxury, actually, I think, to be a scientist, even though one has to go through certain hurdles. But at the end of the day, it's really a luxury, and it can be extremely rewarding at different levels also to develop a certain personality. A specific interest of mine in surpassing the frontier of knowledge in science is really in the field of infectious diseases. So really acquiring more knowledge that would allow really to understand the mechanisms behind at least one of my interests is really bacterial diseases, and to have means to develop research that can lead to new therapeutics. Specifically in the context of treating infections caused by clinical bacterial isolates that are multi-resistant to antibiotics.